Hey everyone, Math 106, Section 4.1, Part 2, Proportions. So suppose we have a worksite generator providing electricity for lights and power tools at a worksite. In 6 hours, the generator uses 13.8 gallons of diesel fuel, but we need to run it for 14 hours. How many gallons of diesel fuel will we need for that? This is the type of question that can be answered with proportional thinking. So a proportion is two fractions that are set equal to each other. So here's an example of a proportion. We have 3/8 equal to 27/72. We have an equal sign, so we know that these two things are equal to each other. Let's make sure that they are. So let's divide these out and get a decimal number and make sure that they are equal. All right, 3 divided by 8, we get 0.375. And 27 divided by 72, we get 0.375. So we get the same decimal. Those two fractions are equal to each other, and we have a true proportion. Now, ahead of time, we're going to know if these things are equal. So we're going to do a test to see if they are equal. So there's one way we can do it. Another way is the cross product rule. So if we have a proportion set up, and I just stuck in letters for the numbers, A over B equals C over D, then what we can do is known as cross multiplying. We can take the top of one fraction and multiply it by the bottom of the other fraction, A times D. So there's AD. And the other way, we can take the bottom of the first fraction, multiply by the top of the second fraction, and get B times C. Now, if this is a true proportion, then when we do that cross multiplication, we should get equal numbers there. So let's try it out. Here's an example. 3/5 equals 6/10. So one cross product here, we got 5 times 6, and that gives us 30. And the other cross product is 3 times 10. So no matter which way we go, we get the same number, 30. So that means this is a true proportion. All right, now I've got an example here. One of these is true and one is not. So let's do the cross product. We got 7 times 6. That is 42. And then the other way, we have 2 times 21. And that checks. They're both equal to 42, so that is a true proportion. But for this one, we got 8 times 7. Is 56, and the other way, 10 times 5, is 50. So those do not equal, not a proportion. Your turn number 1. Determine which one of those is the true proportion. And just a reminder that I don't stop the video for your turn, so just go ahead and pause the video, work on the your turns, and then turn it back on. All right, for this one, we're going to cross multiply this way. So we got 9 times 36. That gives us 324. And then the other way, right, there's that way. And then this way, we have 4 times 81. And that also gives us 324. So this is a true proportion. And the other way, we've got 6 times 56, and that gives us 336. And then the other way, we've got 11 times 30 is 330. So those are not equal to each other, so this is not a proportion. Now the proportions we've seen so far have been all filled with numbers, but that won't always be the case. There will be times when one of the slots has a variable in it instead of a number, and in that case, we're going to be solving the proportion. So to solve these proportions, we can actually use the same rule that we use to check to see if it is actually a proportion. All right, so our example, three over 27 equals x over 117. So we're going to combine two skills to solve these. First is cross multiplying, just like we saw before, and then we're going to solve the equation that results using the same techniques that we used last lesson. All right, so cross multiplying, first this way, we got 27 times x, and this way, we've got 3 times 117. Now, when writing multiplication with a variable, you don't need to include the operation. If we write 27x, we're assuming that multiplication is the operation. Whenever you have a number next to a variable, it's multiplication. So let's write it like that, 27x, and over here, that's going to give us, let's see, 351. All right, now we need to get the x by itself. Right, we're solving for x. That means to get this thing by itself on one side of the equation. But it's got this 27 attached to it, so we need to get rid of that. And we're going to do the opposite operation. We have multiplication here, so to get rid of the 27, we do division. So we'll divide both sides of the equation by 27. And then 351 divided by 27 gives us 13. So x is 13. And now to check, you can either stick 13 back up in there and do another cross product to make sure you get the same number, or divide those out in your calculator and make sure you get the same decimal. In this case, when I checked, I divided them out and we got 0.1 repeating for both of the fractions, 3 over 27 and 13 over 117. So that checks. Your turn number 2. Solve the following proportions and check your answers. Oh, make sure you include units in your answer if there are units in the problem. And I'll discuss that a little bit more in a minute. Part A, start by cross multiplying. So I'm going to do 2 times n, or 2n, equals 10 times 5. So 2n equals 50. Now we'll solve, so divide both sides by 2, and n equals 25. All right, so if we do 10 divided by 25, and 2 divided by 5, we get 0.4 for both of those, so that checks. All right, part B, n over 28 equals 3/7. All right, so we'll cross multiply. All right, 28 times 3, and n times 7. All right, so that gives us 7n equals 84. Now we'll divide both sides by the number next to the variable, number being multiplied there, 7. Divide each side by 7, we get n equals 12. All right, now to check, 12 divided by 28 gives us 0.429. It's probably rounded. And then 3 over 7 gives us 0.429. Part C. Now for the first time we see some units here. And what we need then is some consistency in the proportion. Notice neither of these have units. That's okay. because they're consistent. No units here and no units here, so when you divide it out, there's no units. Over here, we got meters on the bottom. That means to be consistent, we have to also have meters on the top. So when we get the answer here, the units on this should be meters. All right, let's cross multiply. We got 4.8 times 9 times 9.6 equals 6.4 times n. When we multiply 4.8 and 9.6, we get 46.08 equals 6.4n. And then divide by the number next to the variable. And that gives us n equal to 7.2 meters. Always be looking at the units. I know in a lot of math classes we're not used to really thinking much about the units. A lot of times we just solve a bunch of problems, get x equals 5. What does that mean? I don't know, it's just 5. Well, in this class we're doing real world math, so we always need units, or almost always. All right, so let's check here. We've got 4.8 divided by 6.4 gives us 0.75. And 7.2 divided by 9.6 gives us, what did I say, 0.75. So we get 0.75 both ways. All right, last one. Cross multiply here. We're going to get 40 times n, or 40n, equals 1.5 times 160. So that gives us 40n equals 240 divided by 40. And we get n equals 6. 6 what? Got to be consistent here. We got no units on top, no units on top. Units down here is seconds, so the units over here is seconds, so 6 seconds. All right, let's see here. 0.15 divided by 6 is 1/4, so that's 0.25 for this fraction. 40 divided by 160 is 0.25, so that checks. Proportions come up all the time, and we can use proportions to solve all sorts of different application problems. So please take a look at the procedure. It's in the box on the next page. It's going to be important to go through this entire procedure each time. Don't skip steps. That's going to lead to mistakes. So start off by reading the problem carefully. In every proportion application problem, we're going to have 3 known quantities and 1 unknown. And those will go into the 4 spots in the proportion. So in the example, we have 3 quarts of paint will cover 165 square feet. Then how many quarts of paint will cover 495 square feet? So we've got 2 quantities with square feet. We've got 1 quantity with quarts. The unknown is the other quantity with quarts. So we're going to have to define a variable to represent that unknown quantity. So quarts of paint, I define the variable Q for quarts. You can do P for paint. Okay, we're given the 3 quarts covers 165 square feet. So step 3, we're going to create a ratio or rate out of one of the pairs of quantities that are related to each other. So 3 quarts of paint covers 165 square feet. Those 2 quantities are related, so let's write a rate. So 3 quarts over 165, and I'm going to use the symbol FT with a 2 exponent, feet squared. Now we're going to set this equal to another rate. Now we need to set up the other rate so that it's consistent with this one. We got the same units on the same side. Now the other known quantity is 495 square feet. Since square feet's on the bottom of this ratio, or this rate, it has to be on the bottom of this rate. So make sure your units are in the same position. Now finally, our unknown is the number of quarts of paint, so Q quarts. Now I've got quarts on top, square feet on the bottom, square feet on the bottom. Our proportion is set up correctly. Now we can go ahead and solve it. We're going to cross multiply. 3 times 495 equals 165 times Q. And now multiplying here, 3 times 495 gives us 1485. And we'll divide each side by 165. And that gives us Q is 9. Now in answering an application problem like this, I want an answer with a sentence telling the number, the units, and what we're talking about. Yeah, something like that, just a short sentence. 9 quarts of paint are needed. And that brings us to your turn number 3. Got 5 application problems there. We can go through those one at a time. Let's start with part A. If 2.3 tons of concrete are required to create an area of sidewalk, which is 15.2 square yards, how many square yards of sidewalk can be created with 18.4 tons of concrete? All right, just a reminder, pause the video while you work on these. So I'm going to move on here. So your turn 3, part A. Now setting up this one, we've got 2.3 tons of concrete, 15.2 square yards, 18.4 tons of concrete. Those are our 3 known quantities. What is unknown is the number of square yards associated with 18.4 tons of concrete. But we do have a rate here. We got 2.3 tons are required to create an area of sidewalk, which is 15.2 yards squared. All right, so there's rate of 2 related quantities. Now on the other side, we are given 18.4 tons of concrete, so 18.4 tons. And we go by the units, not the numbers. So tons goes on top over here, tons goes on top over here. Our yards will go on the bottom. Now we're talking about sidewalk and concrete. Let's see. I'm going to call this A yard squared, A for area. I'm going to come up with a meaningful variable. All right, now we got it set up, so we got units consistently located. Now we can cross multiply this all. So we'll start here, 15.2 times 8.4, or 18.4. And it doesn't matter which side of the equation you put these things on. 2.3 times A. So 2.3 times A. All right, there's our cross products. Now we can evaluate these. 2.3A equals, multiply this out to get 279.68. And then finally, we're going to solve for A by dividing by the number next to A. And A equals 121.6. All right, so we get 121.6 yards squared of sidewalk. Part B. A machinist has to fill an order for 186 construction fasteners. The machinist can produce 31 fasteners from a 12-pound block of steel. So how many pounds of steel will the machinist need to fill the order? So we're given the related rate is 31 fasteners. And 12 pounds. Now we know we need 186 fasteners. So that's going to go on top, along with fasteners on the left, right? 186. And what we know, or what we want to know, is how many pounds of steel will it take to create that many fasteners. So P pounds. So we got fasteners on top, pounds on the bottom in both of these rates. Solve it. Cross multiply, 13 times P, and 12 times 186. So we get 13P equals 2,232. Did I write 13? Oh my goodness. That's supposed to be 31. Transpose my numbers. There we go. That's better. 31P equals 2232. Divide by 31, and P equals 72. The machinist needs 72 pounds of steel. All right. Next up, in arthritis medication comes in bottles which contain 135 milligrams of medication and 850 milliliters of liquid. If a patient needs 27 milligrams of medication, how many milliliters of liquid should be given to the patient? So I'm going to write a rate just for the bottle first. So the bottle. The bottle contains 135 milligrams of medication, so 135 milligrams in 850 milliliters. All right, so here's for the bottle. Now here's for the dosage. 27 milligrams. And we don't know how many milliliters of liquid. So D for dosage, D milliliters. So you got milliliters on top, milligrams on top, milliliters on the bottom in both of these rates. Now we can cross multiply. 135 times D. And the other cross product, 850 times 27. Multiplying these numbers out, you get 22950. Then we'll divide both sides by the number next to the variable, 135. And D equals 170. So 170 milliliters of medication should be given. And if you give the patient 170 milliliters, they will get the 27 milligrams of medicine. All right, next up, homeowner is fertilizing a 5,200 square foot lawn. The instructions on the bag of fertilizer indicate that 18 pounds of fertilizer are required for 1,400 square feet of lawn. How many pounds of fertilizer are needed for the entire lawn? All right, let's start with the instructions on the bag. And that tells us that 18 pounds are required for 1,400 square feet. It's got 18 pounds on top, 1,400 feet squared on the bottom. And on the other side, the entire lawn now is 5,200 feet squared. And we don't know how much fertilizer we need for the whole lawn, so that's the variable. Now you got pounds on top, square feet on the bottom, so we're set up correctly. Now we can cross multiply. 1,400 times P, and 18 times 5,200. Multiply this out, that'll give us 93,600. And then divide both sides by 1,400. And we got P is 66.9. So the homeowner needs 66.9 pounds of fertilizer. Part E. Got a building code. Requires 1 square foot of net-free vent area for every 300 square feet of attic space. So this is for a ventilation. How many square feet of NFVA are required for a 1620 square foot attic? Okay, so let's set up our building code rate first. We got 1 square foot NFVA over 300 foot squared of attic space. Now, we have the same units on top and the bottom, so we have to have some way of telling which is which. So when you have the same units, make sure you indicate units of what. Here we can differentiate by saying the top is the NFVA, the bottom is the attic. So I'm just going to label one of them so that we know. Now we don't know how many square feet of NFVA are required, so I'm just call that N feet squared NFVA on top. We do know the size of the attic. It is 1620 square feet. All right, so now it's clear we have it set up correctly because we included what we were talking about there. If you just put square feet in all 4 of them, who knows? All right, cross multiply. 300 N equals 1 times 1620. Well, 1 times anything is just it, so I'll just get rid of that. Divide both sides by 300, and we get N equals 5.4. So we got 5.4 square feet of NFVA is required. And we saw the problem last time. We were forced to be a little inflexible last time because we didn't have the mathematical tools to really solve them. It was about the roof pitch and trying to get the 12 in the denominator, especially if we're given a pitch. Sometimes we're given a pitch with 12 in the denominator, and sometimes we want to find a pitch with 12 in the denominator. Well, using proportions is going to be a lot easier. Okay, so as we saw last lesson, pitch or roof is the slope, and the equation is pitch equals rise over run. Just like with the slope of line. So in the first example, we're given that the pitch is designed to be 3 to 12. So instead of writing this as a decimal, I'm going to put in 3 over 12 as a fraction for the pitch. And we know that the rise of the roof is 9 feet. We know we want that roof to go up 9 feet. What we don't know is how long the roof needs to be to go up 9 feet if we know that this is the ratio. So I'm going to put in R feet for the run. So we got 3 over 12 equals 9 over R. Now we can solve this. So now we can deal with that 12 in the denominator for pitches just by leaving it as a fraction and then solving it as a proportion. So we'll cross multiply. We got 3 times R. Then we got 12 times 9. That's 108. Divide both sides by 3 and we get R equals 36. So now we know the run of that roof has to be 36 feet. Your turn number 4. A section of a roof runs 80 feet and the pitch is 2 to 10. Find the rise. All right, so we've got a kind of an unconventional pitch on this one. That's okay. So pitch, rise over run. All right, there's our equation. We're going to plug in. We're given that the pitch is 2 to 10. So 2 to 10. If we write that as a fraction, it's 2 over 10. So now we can take 2 over 10 and plug it in for the pitch. The section of a roof runs 80 feet. So we know the run is going to be 80 feet. Actually, we don't really need units here since it's a ratio. So I'll just leave those out. All right, and then R feet for the rise. We're going to find the rise now. Cross multiply, 10 times R, and 2 times 80. So 10R equals 160. Divide by 10, we get R equals 16. So the run of the roof is 16 feet. I say run, go, rise. We're given the run, rise. All right, and finally, your turn number 5, we're returning to the generator problem. So, how many gallons of diesel fuel will be required for 14 hours of generator time? So, we're given that we have 6 hours for 13.8 gallons of fuel. So 13.8 gallons over 6 hours. And that is going to equal 14 hours on the bottom and G gallons on top. So gallons on top, hours on the bottom. Cross and multiplying here, that gives us 6G equals 13.8 times 14. So 6G equals 193.2. Divided by 6. And G equals 32.2. Generator requires 32.2 gallons of fuel. So proportions come up all the time in any field. So this is a very important mathematical concept. All right, that's it for today.